Hello everyone, hope you all are fine today. So yesterday we discussed the various methods of the frequency distribution. Under that we broadly discussed the bar graph and histogram. So today I am going to continue the same topic with difference in the histogram and the bar graph. Are you looking at the both pictures? Both seem same. Then what is the difference between the histogram and bar graph? So starting with the definition of both, in case of histogram, it refers to the graphical representation that display the data by the way of bars to show the frequency of numerical data. So what is the histogram? It is the type of graphical representation that shows the frequency of the numerical data, or you can say the frequency of the quantitative data. But in contrast to that, bar graph is the pictorial representation. It is the pictorial representation of the data that uses bars to compare the different categories. So are you getting the difference? Histogram is the graphical representation to show the frequency of the quantitative or the numerical data, and bar graph is a type of the pictorial presentation that is used to compare the different categories. Okay. The second difference is it presents the quantitative data and bar graph present the categories. So that is the comparison between the different categories. And regarding the third difference, bars touch each other. Hence, there are no space between the bars. When we are talking regarding the histogram, the bars or the rectangle that we are making on the behalf of the frequency that touch each other, and there is no space between the bars. But in case of the bar graph, bars do not touch each other. Hence, there are the space between the bars. So look at the picture, you will better understand. This is the picture of the histogram. In this case, the bar has no space in between. It touch each other. But in case of the bar graph, the bars are quite away from each other. So there is the space. Okay, the next difference. In histogram, elements are grouped together so that they are considered as the range. There will be the range 5 to 10, 10 to 15, 15 to 20, so on. But in case of the bar graphs, the elements are taken as the individual entities because we are taking the different categories. We are not taking the numerical value. So in case of the bar graph, the elements are as the individual entities. And in case of the histogram, it indicates the distribution of the continuous variable, and bar graph present the distribution of the discrete variables. I think you should remember what is the difference between the continuous variables and discrete variables. In continuous, we can choose the fractional value, but discrete is complete itself, or it is the individual value that cannot be divided. Okay. Then in case of the histogram, the class width of the bars need not to be same every time. It can be same, but it is not required that it will be same in every time. And in case of the bar graph, class width of the bar need to be same. Just again look at the picture. In case of the histogram, this class interval will be, it is not necessary it will be same every time. It can be same like 10 to 20, 20 to 30, but it is not every time same. It can increase in size or decrease in size. But in case of the bar chart, it will be same for every category. Now, it is very common question in the exam that the class intervals are given and in front of that frequencies are given and you have to draw the histogram. So it is very easy task to make the class interval, like if it is given like 10 to 20, 20 to 30, 30 to 40, you will take the class interval on the x-axis and frequencies on the y-axis, and you will draw the histogram without any space in between the histogram. But sometime there will be some confusion part, like how to draw the histogram when class intervals are not same. Okay, now the question is how to draw the histogram when the class intervals are not same. So I am going to explain it with the help of example. Just look at the picture. First of all, you have to see this table. In this case, the first row explains the age in years and the second row explains the number of persons, means frequency, the person who are lying in that particular age group. So the age interval is 0 to 5, 5 to 10, then 10 to 20, then 20 to 40, then 40 to 50, then 50 to 80. So do you think anything peculiar in this table? Of course, frequency. It's okay, frequency is continuous, but it is not uniform. Like you can see, there is the difference between 0 to 5, the difference is 5. 5 to 10, difference is 5. But next 10 to 20, the difference or the interval is 10. And so on, it is increasing. So it is not in a uniform manner. So what will we do in that case? We will need some parameters which have some effect as the class size, that is in uniform. So we need the adjusted frequency. We need to find out the adjusted frequency. So what is the formula for that adjusted frequency? That is the minimum class size, minimum divided by class size into frequency. So what is the formula for the adjusted frequency? That is the minimum class size divided by class size into frequency. So with the help of this formula, we have to find out the adjusted frequency for every row. So let's take the first row. Minimum class size, that will be 5. The minimum class size will remain same for the every column. Then the class size itself, it is 5 and the frequency is 7. So we get the new frequency, that is 7. For the second row, minimum class size, as I told, it will be same for the every column, that is 5. And the class size again it's 5 and the frequency is 9. So we get the new frequency, that is the 9. And for the third row, minimum class size, that is 5, and the class size, now look closely, that is the class interval, that is 10 now, and the frequency is 14. So we get the new frequency, that is 7. So you have to apply the same formula for the rest of the rows, and we get the new frequency like 7, 9, 7, 3, 4, 2.5. So on the behalf of these new frequencies, we are able to construct the histogram now. On the x-axis, we always plot the class intervals, and on the y-axis, we will take the frequencies, means the adjusted frequencies. You can use the scales according to your choice, but here I am taking like class 1 centimeter is equal to the 10. Then 2 centimeter is equal to the class interval 20. On the other side, 1 person is equal to the 1 centimeter, 2 person is equal to the 2 centimeters. On the behalf of the new frequencies, our histogram is ready now. I will try to show the close view of the histogram. Now your histogram is ready, but the one thing you should observe closely, the class width will not remain same every time. It will change according to the intervals. So this is the way to draw the histogram when the class intervals are not same. So this is the end of the today's class. If you have any query, you can ask me. Okay, thank you.